Section 1.6, Relations and Functions. Please write down the essential question. How can I identify if a relation is a function? There's actually another essential question. How do I find the domain and range? Scrolling down here, there we go. So we're going to start talking about a mapping diagram. I'm going to refresh your memory on domain and range. Domain always goes with the X value and is called the input. Range goes with the Y value and is called the output. It generates a set of ordered pairs. So as you can see here, 2 is mapped to A, B, and C. That creates 3 ordered pairs, 2A, 2B, 2C. X are the inputs, domain. The Y's are the outputs, the range. A relation in which the first coordinate, that's the X's, is never repeated is called a function. A relation is a set of ordered pairs. In a function, there is only one output for each input. So each element of the domain is mapped to exactly one element in the range. So basically, that means when you're looking at a set of ordered pairs, the X's cannot repeat. If they do not repeat, it is a function. If the X's repeat, it's not a function. We don't care what happens to the Y's. Here's an example. So each X value is the domain, has only one matching Y value in the range, right? So if we look at this carefully, what our focus is, I'm going to do a quick highlight here. Our focus, when we're determining if something's a function, we're only looking at the X values. They don't repeat, 1, 2, 3, and 8. So I'm going to write the X values do not repeat. So it is a function. Here's some other examples. Here's an example of not a function. This is Y. 2 is mapped to A, 2 is mapped to B, 2 is mapped to C. We're determining if it's a function. We're looking at the X's. They repeat, not a function. The other mapping, A is mapped to 2, B is mapped to 2, C is mapped to 2. A, B, C. They're different. The A's do not repeat, the X's do not repeat, so it is a function. The Y's, as you can see, repeat. It doesn't matter. We're skipping example 1 and we're going to example 2. You can cross off example 1, actually. We will not be doing it in class either. From players, well, first of all, let's look at the directions. Determine whether each relation is a function. So let's highlight so we know what we're doing here. This is what we're doing. From players on a basketball team to their points scored for a specific game. So I created the ordered pair, players to points. So let's see. Let's do some examples. Well, Tim is a player. Maybe he scores 17 points. Adam is a player. Maybe he scores 17 points also. Corey is a player. He scored 23 points. This is going to be a function. The answer is yes. It is a function. The X's are not going to repeat. Every player on the basketball team is a different person. Let's scroll down to here. From car models to car colors. Car models to car colors. So let's do some examples. Ford blue. Ford yellow. Toyota blue. Well, here's the deal. This is not a function because the X's are repeating. You can have two Fords that are different colors. That is not a function. From day of the week to the number of hours in a school day. Well, day of the week. Well, let's see. We have Monday. And there are number of hours in a school day. Well, let's see. 9:30, 10:30, 11:30, 12:30, 1:30, 2:30. Yeah, like 6.5 hours. Tuesday, 6.5 hours. Wednesday, 6.5 hours, and so forth. Yes, it is a function. The Y's repeated, but the X's aren't. We have unique days of the week. They will not repeat. Example 3, the set of points. We are going to do this. We're going to highlight. We're determining whether each relation is a function. Well, look at your X values. They do not repeat. So yes, that's a function. Let's look at the next group. 4, 6, 12, and 13. They don't repeat either. And let's look at this one. 2, 3, 5, 2. Oop, they repeated. The answer is no, not a function. Example 4. How do you find the domain and range by looking at a graph? And how do you decide if the graph is a function? Well, what I did ahead of time is I labeled each of the points. On your notes, you have the points, but not the ordered pairs. So I would take the time right now to stop the video and record the ordered pairs. And because what we're going to do over here is we're going to list them. So -4, 3, 4, 3, -2, 1, 2, 1, and 0, -2. So I'm going to highlight something. The domain are our X's, and the range are the Y's. So the domain is -4, 4, -2, 2, and 0. And the range is going to be 3, 1, and -2. Notice I did not go on the range 3, 3. I didn't write it twice. You don't have to write it twice. Just write it once. And notice there is no particular order. I just started writing them down. You don't have to have them from lowest to highest, nothing like that. You just have to list them. All right, -4. I'm just double checking before I move on. Perfect. Well, let's go back and determine, is this a function? Well, let's look at our X's. Let's look at our domain. None of them repeat. So therefore, yes, this is a function. Example 5, we are going to do in class. And actually, we're going to also do example 6 and talk about the vertical line test in class. And here you go. Pause the video, answer the video questions in your notes, and we'll see you tomorrow.